All right, today, guys, we're going to do a little acid bases. So let's start with the first slide. All right, what we're going to do is start with acid bases. Okay, acid bases are special class of compounds that are really work together real nicely. So a lot of this we've done already. So just understanding what an acid and bases are is a subject for the first little bit here. So let's go through a couple of things. Acid bases are generally items you find around the house. So if you look at the picture, you'd see, you have your orange juice, your tea, your baking soda, milk, fruit juice, tomatoes. Anything you see here generally has, these alkaline batteries generally have some acids and bases in them. So you've probably seen these things before. Um, Basically, these are relative compounds that have specific chemical and physical properties. Scientists knew this for a very long time, that they were, had special properties, but it wasn't until a little later on that they figured out exactly what was going on. Just a couple of things. So as you fill out your paper there, I guess you can jot these things down. Okay, we find them in fruits, and vegetables. Certain foods have acid bases in them. Okay, your blood pH is an important one. Your blood has to be between 7.35 and 7.45. For and then in digestion in your stomach, there's hydrochloric acid. Maybe you know that already. If your blood pH is not between these two ranges, then this range, then you can have all sorts of health problems and things like that. So soil growth or plant growth, then your soil pH is really important. Certain plants can grow at certain pHs. You've heard the word pH. We'll go over that a little bit later. That has to do with how much acid or base there is in the soil. Environmental things. You've heard about the environmental issues with, basically whether the ocean is acid or base, or with acid rain. Cleaning products. We use vinegar for cleaners and ammonias for cleaners, and also drain cleaners. Most cleaning products that would normally kill bacteria are going to be in the acid base range. Okay, and last here is batteries. Okay, generally batteries are going to have an electrolyte in them that contains an acid or a base. So a little overview. All right, naming acid bases. This is page 2. In naming acid base, typically what we do is we would use, I'm going to go with my pen here. Okay, if you take a look up here, binary acids are acids that have an H plus and some other non-metal. So that's what binary acids would be. So you're looking at having an H plus in here, which is going to be most important. All right, and then so if you have a binary acid, you would have H plus some other negative ion. That would be a single element. So in this case, if you had, HBr, you would have hydro. You would use the word hydro in front for the hydrogen, and then the nonmetal's name, and then you'd end it with ic acid. So you would call it hydrobromic acid. If you had HCl, you would call that hydrochloric acid because of the Cl there. So you're going to start with hydro, you're going to end with the non-metal name modified, and then an ic acid. Okay, a ternary acid here is going to be when you have a polyatomic ion. All right, so the rule is really, if your polyatomic ends in ite, then you'll be an us acid. And if your polyatomic ion ends in ate, then that would be an ic acid. So in this case, you see the nitrite ion would be nitrous acid. The nitrate ion would be nitric acid. Okay, so again, you can see this on a lot of them. So if you name a few of these, let's just do a couple. Okay, this would be hydro. I'm not easy with the mouse here. Chloric acid. I'll get better at this, I promise. All right, and then this would be the chlorate ion. Okay, so you would call this chloric acid. Again, why is it chloric? It's chloric because the chlorate ion is ClO3, and because that ends in ATE up here, it would be ic acid, so chloric acid. So, you could finish these on your own. Check what we're doing here. All right, as far as bases are kind of easy. You're going to take the metal, sodium, and you're going to take the base part, which is the OH ion. It tells us it's base. Get to that in a minute. Okay, and that would be sodium hydroxide. Okay, so that's probably easy to do. You can do that on your own. All right. All right. So basically, we'll do some properties. And what the properties of what acids and bases can do. What can they actually do? All right. So basically, a property of some acids. I'm going to go through this pretty quickly. Okay, and properties of bases if you're following along. Number one, acids are going to produce your H plus. Okay, and what they'll do is the H plus will then go over to a water molecule and create this. Do that a little bit later, but if you have H plus or H3O plus in solution, then you would be an acid. Again, these are solutions, so we follow all the rules of solutions. I know everybody loves that, but that's how it goes. All right. In a base, you would produce hydroxide ions. Okay, so as long as you have hydroxide ions in solution, you would call that a base. All right, acids are going to have a sour taste to them. Okay, so you probably in fruits and vegetables and some sour fruits, and use some citrus means citric acid. Okay, and vinegars also have a sour flavor to those would be acids. All right, bases are going to have a bitter taste to them, and they're going to feel kind of slippery. So sometimes we think of these as soaps. Soap is generally a basic kind of thing. Yeah, see, my handwriting's getting better. All right, really important to know that acids are going to react with group 1 and 2 metals or any active metal to produce hydrogen. We've seen this before in our rocket lab. All right, and it can also work with zinc. We've seen that before. Okay, and we'll see the reactions for this a little bit later on, but you know that single replacements will produce this the way it goes. All right, acids are definitely electrolytes. Remember your acid, bases, and salt. You drink electrolytes, you do exercise, you get your good abs. Don't forget, that's your acids. Okay, so you're gonna have ions in solution here. Really important that you want to remember ions. Okay, and it's going to be AQ. Sorry, I keep doing that. AQ. Wow. All right, good. All right. Bases, the same thing. They're also electrolytes. Really important. Okay. You've probably seen indicators before. You probably heard them if you haven't. Okay. Indicators are, they're molecules actually we get from plants. Okay. And when they sense an acid base or they react with an acid base, they actually change color. So they let us know that acid or base is present. So litmus is a special indicator. And when that hits acid, it turns red. It gives us an indicator that it's there. Phenolphthalein is also an indicator, and that is colorless. Okay, this you can find on table M. Okay, no need to worry about it now. We can get to that a little bit later, but table M would be important. Okay, the same litmus would turn blue in a base and pink in phenolphthalein. So these are just some acids and base indicators that you may want to memorize. This way, at least you know some general indicators, and these are the ones that have been used most common. Okay. And last but not least, a couple of reactions. Okay, really, really important. You want to know this, and there's going to be you have to know this for later on. Is that acids will react with bases, okay, to form water. Really important, and salt. Okay, so that's going to be an important thing, and the same thing with a base. The bases are going to react with acids to form a water and a salt. So we're going to do a little bit more of this on another day, but at least we know that this is a really important thing you have to know. And scientists knew this a long time ago. They realized that when they mixed the two, that the acid and the base would disappear and two new compounds were formed. And that was kind of strange to them, so it took a while to figure it out. All right, so this ends the first couple of slides. All right, we're going to come back and do the next part in a few minutes. I just wanted to stop here. Okay, so this is slides, the first 3 slides. All right, and then we can get back and do the next ones. Okay, see you in a bit.